Oh, welcome to my channel. We will be doing question number 2, chapter 10, permutation and combination. Okay, so this question number 2, it has two parts, A and B. So let me do 2A first. And the question is, Gene has 9 different flags. Find the number of different ways in which Gene can choose 3 flags from her 9 flags. So this is pretty straightforward. Uh, you know the concept of combination, that she had to choose how many? Um, 3 from her 9 flags. So it is 9 combination 3. Okay. So how many ways she can choose uh, 3 flags from 9? So this is 9 choose 3, and this comes out to be 84. Okay, this is pretty straightforward. Now part 2. Jean has 5 flagpoles in a row. She puts one of her 9 flags on each flagpole. Calculate the number of different 5 flag arrangements she can make. Okay, this is interesting. So first of all, from her 9 flags, how many ways she can choose 5? Okay, so that is going to be 9 combination 5. So once she have those 5 flags in her hand, she have to put them on 5 poles, and she can change the order every time, right? So remember, if I have 5 flags, and I have to put them on 5 poles, then how many different orders I can make? That's going to be 5 factorial. Okay, for example, let me explain it a little bit. If I have 3 items, A, B, and C, then in how many different ways I can put them in the line? Okay, so A, B, C, and then I can make A, C, B. Then I can make B, A, C, and B, C, A. Then I can make C, A, B, and C, B, A. So this is 1, 2, 3, 4, 5, 6. And 3 factorial is 6. Okay. One other way to understand is that if I have 3 items, then and I have to put them in, let's say, in these slots, right? So in the first slot, what are options I have out of 3? 1, 2, 3. So I have 3 different options. In second one, how many options do I have? So out of 3 items, let's say, okay, A, B, and C, out of 3 items, I have in first slot, I have option to put 3 in from them. In the second one, I have only option of 2 because 1 is already gone. So this is 2. And then the last one, I have only option of 1 because 2 are gone, right? So this is 3 times 2 times 1. So this is 3 factorial. So that's why the number of arrangements would be 5 factorial, 3 factorial, whatever it is. Okay. Now I have chosen 9 combination 5 is the number of ways I can choose 5 flags out of 9, right? And each group of flags that I have chosen, I can arrange them in a 5 factorial manner, right? So the answer would be, if I calculate this number, this is going to be 15,120. Okay, I hope this is clear. Now part B, let me change the color. Okay, for part B, the 6 digits of the number this are rearranged so that the resulting 6-digit number is even. Okay, so I have given this number 3738,925. 738,925. Okay, I have to rearrange these numbers to make even numbers. So how many even numbers I can make? Okay, you see there are only 2 even numbers here, 8 and 2, right? Let's say I decide to put 2 at the end. So now I have only 1, 2, 3, 4, and 5 numbers, right? So 7, 3, 8, 9, and 5. So how many different ways I can arrange them? This is 1, 2, 3, 4, 5. So of course, we have, as we found before, there are 5 factorial different ways I can arrange these numbers. And I can put 2 at the end of each one of them. So I have so many even numbers which have 2 and the rightmost number. In the same way, I can make 7, 3, 9, 2, 5. So remove this 8 and put 8 at the end. So again, I have 1, 2, 3, 4, 5. So this is going to be 5 factorial different arrangements with 8 at the end. Okay. And if I calculate this number, this comes out to be, I believe, 240. Okay. So there are 240 different even numbers I can make using these digits. Okay, I have this all clear. If you have any questions, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.